بسم الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضة لغات، أهلا بكم. اليوم سنتناول درس جديد في مادة الجبر، وهو مراجعة عامة على المصفوفات والمحددات. طبعا احنا عارفين المصفوفات والمحددات دي مهمة جدا جدا في حياتنا اليومية، لأن النظام المحددات أو المصفوفات هي أنظمة رياضية بتحل مشاكل كتير جدا جدا في مجتمعنا، في المجتمع عامة، وفي المجال الصناعات خاصة. لأن المحددات في محددات ثنائية ومحددات ثلاثية وفي محددات أكثر من ذلك على حسب الترتيب المحدد من حيث الصفوف والأعمدة، كذلك المصفوفات. وطبعا المصفوفات دي بتحل مشاكل كتير جدا جدا في إيجاد مجموعة حلول للمتغيرات س ص ع أو إكس واي وزد. فهنا عشان كده مهمة جدا جدا علم المصفوفات وعلم المحددات، موجودة في جميع نواحي العلوم الموجودة في جميع الكليات المصرية. Welcome my dear student in our math program for secondary 3. Today we are taking new lesson. It's titled Revision about matrices and determinant. My dear student, revision of matrices and determinant. Look at the first example. Find inverse A or A power negative 1 if matrix A is 1, negative 2, 3, negative 4. My dear student, at the first, A has inverse if determinant not equal 0. Solution: determinant of A 1 times negative 4, negative 4. Mean diagonal 1 times negative 4 minus negative 2 times 3 equal positive 6. Answer is 2. Determinant equals 2, not equal 0. Then, my dear student, inverse 1 over delta, and look at the matrices. We change the mean diagonal negative 4 and 1. Look at, my dear student, we find inverse of A 1 over delta 1 over 2 multiply matrix, but this matrix we change or replace the mean diagonal 1 negative 4 is negative 4 1, and change the inverse of the second diagonal. Negative 2 became 2, 3 became negative 3. Then A inverse equals 1 over 2 multiply matrix negative 4 2, first row, second row, negative 3 1. By distribution or multiply each term by 1 over 2 equals negative 2 1, negative 3 over 2 1 over 2. This is inverse of A. My dear student, prove that in another example 3, prove that, my dear student, there is no multiplicative inverse for the matrix. Matrix A 2 4 3 6. My dear student, the conditional or condition, necessary condition to find inverse of A, determinant not equal 0. If the determinant equals 0, the matrix has no multiplicative inverse. Find the value of delta. Delta A multiply the mean diagonal 2 times 6 equals 12 minus 4 times 3 12. Answer is 0. Then delta equals 0. This matrix has no multiplicative inverse. Another example. Find the cofactor matrix of the matrix. Matrix A 1 2 3 2 3 2 1 2 2. My dear student, the required finds the cofactor matrix of the matrix. What is the meaning cofactor matrix? Each term has cofactor matrix. Element A. Element A11 or 1 has cofactor determinant. We look at A11 or element 1, first row, first column. We simplify from first row and first column, then the remainder determine 3, 2, 2, 2. We find the value of determinant 3 times 2, 6, minus 2 times 2, 4 equals 2. Each element in matrix A has cofactor matrix. Solution. C11 positive the first determinant, 3, 2, 2, 2. Answer is 6 minus 2 minus 4 equals 2. C12 negative second determinant, 2, 2, 1, 2 equals 4 minus 2 equals negative 2. C13 means the element of the first row and third column. My dear student, we calculate 2 times 2, 4 minus 3 times 1 equals 3. This is the first row in cofactor matrix, 2, negative 2, 1. Also by the same method, C21 means second row, first column. We delete the second row and first column and find the determinant 2, 3, 2, 2 with negative sign equals 2 times 2, 4 minus 2 times 3, 6 equal negative 2 times negative 1 equals 2. C22 means second row, second column. 1, 3, 1, 2 equals 1 times 2, 2 minus 1 times 3 equals negative 1. C23 with negative sign, calculate the value of determinant equals 0. By the method, calculate C31 third row, first column. Determinant 2 times 2, 4, 3 times 3, 9 equal negative 5. C32 with negative sign, calculate the value of determinant 1 times 2 minus 2 times 3 equals negative 4 times negative 1 equal positive 4. 3, 3 determinant 1, 2, 2, 2, 2, 3. Answer is negative 1. We form all rows. The cofactor matrix of the matrix A is C. It's a symbol C. Write cofactor matrix 2, negative 2, 1, the first row, 2, negative 1, 0, second row, negative 5, 4, negative 1, the third row. A joint matrix. What is the meaning of a joint matrix? Joint matrix, if A is a square matrix and C its cofactor matrix, then the joint matrix of A, which denoted A joint, is transpose of matrix or cofactor CT. A joint means C transpose, T transpose, C cofactor matrix. My dear student, a joint matrix means cofactor matrix transpose. Example, FB matrix equals 2, 0, 3, negative 1, 2, negative 1, 0, 5, 1 is a square matrix. Its order 3, 3. Find B adjoint. Then find BB adjoint. And B adjoint times B, what do you notice? Is B adjoint equal B joint B? Look at the solution. My dear student, A adjoint or matrix adjoint, we must find cofactor matrix. What do you mean A adjoint? Adjoint matrix equal cofactor matrix but transpose. What do you mean transpose? Transpose means first row became first column, second row became second column, third row became third column. Each matrix is or a square matrix has cofactor matrix. By using determinant, find the cofactor matrix. After that, we denote it by C matrix and find C transpose to find the adjoint matrix. My dear student, look at the solution. Cofactor matrix B equals all determinant. Look at the first is positive, second determinant negative, third positive is the first row, second row negative determinant, positive determinant, negative determinant, third row positive determinant, minor determinant, negative minor determinant, positive third determinant. My dear student, this is called cofactor matrix. How to find cofactor matrix? Each element in matrix B, we delete the first row and the first column to find the first determinant. B11 means determinant after delete the first row and the first column. Note that, my dear student, cofactor matrix has sign. Start from positive, negative, positive, negative, positive, negative, positive, negative, positive. Don't forget the sign of each element in cofactor matrix. After calculate these determinant, then we find the cofactor matrix 7, 1, negative 5, 15, 2, negative 10, negative 6, negative 1, 4. This is cofactor matrix. Adjoint matrix equals C transpose. We find C transpose. This is adjoint matrix. 7, 15, negative 6, 1, 2, negative 1, negative 5, negative 10, 4. Adjoint, we replace first row with first column, second row, second column, third row, third column to calculate C transpose or cofactor matrix transpose. When multiply B adjoint, this is B matrix times adjoint matrix. What is the result? When multiply, my dear student, B times B adjoint, what is the condition to multiply two matrices? My dear student, the condition, my dear student, must be number of column of the first equal number of the row of the second. Its order, the first matrix 3, 3, second matrix 3, 3. Then the number of column equal number of row. The product is possible. Answer is, my dear student, when we find the first row times first column. 2 times 7, 0 times 1, plus 3 times negative 5. This is the first element, or A11. The answer is negative 1, 0, 0, 0, negative 1, 0, 0, 0, negative 1. What you note, my dear student, this is diagonal matrix. Answer is, by using determinant equals negative 1. Negative 1 times negative 1 times negative 1 also equals negative 1. When we find B adjoint times B, we put the element of B adjoint 7, 15, negative 6, 1, 2, negative 1, negative 5, negative 10, 4 times B matrix 2, 0, 3, negative 1, 2, negative 1, 0, 5, 1. What is the product, my dear student? By the same method, we find same cofactor matrix. Negative 1 diagonal matrix. Negative 1, 0, 0, 0, negative 1, 0, 0, 0, negative 1. Answer is negative 1. What you note? You note that, my dear student, B joint equals B joint B equals negative 1. So we can generalize this by this rule. B joint equal B joint B. This rule equals BI. My dear student, look at another example. Find the value of K if A matrix 2, 1, 3, K 0, 1, 2, 4, negative 1, singular matrix. What you mean singular matrix? Singular matrix determinant equals 0. Number 2, matrix B, negative 1, 3, 1, 0, K2, 3, 1, 4, non-singular matrix. Solution. Matrix A is singular when delta equals 0, or when we find determinant must be equal 0, singular matrix. Non-singular, not equal 0. My dear student, we find the value by using the value of first row equals 0. Determinant must be equal 0. 2 times the minimum determinant 0, 1, 4, negative 1, minus 1 times determinant K1, 2, negative 1, plus 3 times determinant K0, 2, 4 must be equal 0. By using multiply, therefore 2 times 0 minus 4 plus negative K minus 2 plus 3 multiply bracket 4K minus 0 equals 0. Therefore, negative 8 plus K plus 2, we find the value of K equals 6 over 13. Since B is non-singular matrix, then determinant of B not equals 0. Singular matrix, delta or determinant value equals 0. Non-singular matrix, delta or determinant of B not equal 0. Delta, we find the value of determinant of B not equal 0. Therefore, negative 1 multiply minor determinant minus 3 multiply minor determinant plus 1 multiply minor determinant not equal 0. Therefore, my dear student, the equation not equal 0 to find the value of k. Therefore, 7k not equal 20, k not equals 20 over 7. What you mean k not equal 20 over 7? K is real number except 20 over 7. K belongs to real numbers except 20 over 7. Another example. Look at AD x plus 1, BE y plus m, CF z plus n equals, my dear student, we can divide this matrix into two matrices by using separate the third column x plus L, y plus m, z plus n. We can divide the first determinant by using two determinants. The two determinants, the third row in each one, formed from the third column in the given determinant. The first is ADX, BEY, CFZ. The second determinant, ADI, ADL, BEM, CFN. Expand using the factors of the second row. Is the delta determinant by using the second row. Second row start from -2, 4, 3. What is the sign? Negative, positive, negative. -2, it's a sign negative. 4, it's a sign positive. 3, it's a sign negative. By using the second row, then -2 times minor determinant, 4 times minor determinant, -3 times minor determinant. Answer is 2 multiply -2, 2. 0 times 5 minus -2 times -1 plus 4 times bracket continues 1 times 5 minus -2 times 3, -3 times bracket contains 1 times -1 minus 3 times 0. Answer is -4 plus 44 plus 3 equals 43. My dear student, look at important example. If omega is 1 of cubic roots of 1 and I square root -1, prove that. Delta, look at the determinant, 1i omega, omega I negative omega 0, omega square I negative omega square, omega equals 0. My dear student, we know that omega is one of the roots of cubic root 1. Omega power 3 equals 1. We know that I equals square root -1, I power 2 equals -1. I power 3 negative I power 4 equals 1. But omega plus omega square plus 1 equals 0 and omega power 3 equals 1. My dear student, look at the solution. Delta equals 1. Calculate the determinant. 1 multiply minor -I multiply minor plus omega square multiply minor. We know that, my dear student, negative omega square, -I multiply omega square. Answer is negative omega square I plus omega square, negative omega square plus omega square equals 0. Then determinant equals 0. Look at, my dear student, omega square, negative omega square plus omega square equals 0. Don't forget omega power 3 equals 1. but I power 2 equals what? I power 2 equals negative 1, I power 3 equals negative I power 4 equals 1. I is imaginary number, square root negative 1. Omega is one of root of unity. Don't forget, omega square plus omega plus 1 equals 0. Omega square plus omega equal negative 1. Also omega plus 1 equals negative omega square. My dear student, by the end of the lesson, we find the cofactor matrix by using determinant and a joint matrix, and we know that if we find a joint of any matrix, multiply its matrix, answer is equals negative 1. Why? Because when we find product of matrix and its joint, the answer is matrix, but the column matrix, diagonal matrix is negative 1. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.